Hello everyone. In this video, we're going to do a OO analysis on the card game wall. Here's a problem statement. For step 1, we are going to identify all the objects. In order to do this, we just extract all the nouns in the problem statement. I got the nouns as card, game, wall, player, deck, pile, round, and rank. So when do the analysis, the first step we need to do is to eliminate the repetitive ones. For example, game and wall, they're the same thing, so we can get rid of one of them. Now deck and the pile, they're also the same thing, so I'm going to get rid of pile here. And when you take a look at the round, in this problem statement, we don't do much about the round. It doesn't have attributes and it doesn't provide much service, so I'm going to get rid of this now. And now let's take a look at the rank. Rank is part of the card. It's one attribute of the card. So I'm going to get rid of rank. That left us card, game, player, and deck. When you do the analysis, when you try to find the objects involved in your application, the first thing you need to think about is, does this object remember something? That's a property of the objects. And the second thing you need to think about is what kind of service this object is going to provide. If an object doesn't need to remember anything or doesn't need to provide any service such as round in our problem statement, then you can get rid of it. And some noun, like rank is one attribute of a card, then you can get rid of that one because it's just an attribute, it's not an object here. And also there could be some nouns that doesn't really do much for this application. Then you can get rid of them. That's our step 2. By extracting the nouns, we create a set of objects. Now for step 3, we need to create the CRC card for these essential objects, or we call them core objects. The CRC card looks like, here's a class name, so that's the first C. R stands for responsibility, and C for collaborators. For each CRC card, it has a name, has a responsibility, has a collaborator. The responsibility part, usually we think about what does card know. So card knows about the rank. So that's the attributes of the card. And what can it do? It can return the rank. The collaborator part, you don't need to fill all the collaborator now. Later on, when you play the scenario, it will get, you can modify and keep collaborators updated. Collaborators are some objects that help these objects to do something. So we call them collaborators. So for card knows about rank and it knows how to return a rank. It's a simple object. Now let's take a look at the deck. For deck knows about cards. That's a set of cards. So here's a collaborator for this property. This knows something. And the service about deck has to know how to create cards. And deck has to know how to shuffle the cards. And those are the service deck can provide. So it can create, it can shuffle, it can deal a card. All the collaborators here are cards. And also it can answer questions like if the deck is empty. Now let's take a look at player. For player class, it knows about hand. So each player knows about hand. this hand object doesn't show up in the problem statement, but when you try to think about the player, when you think about this class, it makes sense for player to have to keep track of a hand of cards. So we throw in the hand, and here's a hand class. When you do the problem analysis, when you extract the nouns, sometimes like hand didn't show up in the problem statement, but when we think about player, try to model player, we need to have this service object, so we add it in. And player also need to know about the winning pile here. The service player provide, it has to be able to draw a card. When it draw a card, the collaboration object, collaborators are deck, because you have to ask deck for the card. In the hand, you have to add this card to your hand, and card. Place a card, similarly, and set aside the card and return the score determined by winning pile. So that's for player. Now let's take a look at the hand. Hand is just a set of cards, and it only provides two services like add and remove. And now let's see game. Game need to know about the players. I need to know about the deck. And the logic of the playing, the game playing, like determine who wins the round, give winning cards to player, determine who wins the game. So pretty much the gaming logic is in this game class. This game acts as a controller object. We will continue about the CRC card playing in the next video. In this part of the video, we are going to play the CRC cards we just created. So the first thing we need to do is to invent the scenarios. How do you use this application? What should those objects do? What happened when some action is taken? How the objects cooperate with each other. You should start with the essential ones and the easy to do ones. So how about, let's take a look at the game. What should happen? So the scenarios. The first one will be shuffle the cards. That's how you start the game. Now after that one's done, you're going to say one player draws 3 cards and another player draws 3 cards. When you write the scenario, you need to be concrete, very concrete. So for example, if you're trying to design an application for a library system, one scenario could be Eric check out a computer science 1 book on September 19th, 2015, something like that. Or Emma returns a book 2 weeks late. What's the book's title? And 2 weeks late, when did she check it out? When did she return? So you need to play the scenario and do a detailed one. Let's continue with this analysis. Another action would be each player selects one of 3 cards from his or her hand and place it face up in front of them. So it's a detailed scenario. Then determine if the rank of both cards are the same, then the game scenario there. Another one, after playing the card, each player draws 1 card from the deck to replace the card. So that's another essential scenario. For this game one, pretty much we follow the game action. The scenarios are a sequence of action. So let's write each one down, those essential actions, and then the last one will be the game ends when the deck is exhausted and the player with the most cards win. So you see, when you think about this scenario, this game ends and deck exhausted, and you need to determine who wins. So those are the scenarios. When you think of something, you need to write them down. Start with easy ones and add with detail. Now let's play the card. The first scenario, shuffle. You need to think about which object can do shuffle. So in this case, it's pretty simple. It's a deck object. because deck object knows about the card. When deck does the shuffle, actually it's a two action. Deck first need to create a deck of card, then it do the shuffle. So this shuffle action, the solo object here is a deck. Deck knows how to do shuffle. Now let's take a look at the second scenario. Draw the initial 3 cards. About this scenario, now think about who's going to draw. That will be player object. Player object is going to draw a card, but who's going to give player the card? That will be deck object. So deck deals card. So now you see this draw initial 3 cards. The first object starts the action, that's player. Player try to draw. The collaborator object deck will deal the card. Then after deck deal the card, player got this card. Player need to add it to his or her hand. So player knows about the hand object. Now you see the third object kicks in. That's player knows about the hand object. And player gave this card to the hand object, then hand object add the card. So you see, this draw 3 initial cards. The involved object here are 4 objects. Start with player. Player draws a card, then deck deals a card, then player add this one to the hand. Player gave this card to the hand to add. So those, when you play the CRC card, each person, each team member should be assigned roles. Like some team member holds the player card, some team member holds the deck card, some team member holds the hand card, and some team member holds the card object. So when you do the collaboration, you should move the cards around. If for this action, those 3 cards collaborate together, then you should put them closer to each other to play the card. Now let's see the third scenario, play card. This action about play card, so we identify the object who should play. So that will be player. Player plays a card, but involving the collaboration object, the collaborator here, hand need to remove a card. And after hand remove the card, player plays a card, hand remove the card, and game object need to determine who wins. And how does game object know who wins? Game has to ask a card about the rank. Game has these 2 cards. It's going to ask a card about the rank, then do the comparison. And when it asks a card need to return the rank. So card object is involved too. And after the comparison here, the game object, it need to say, hey, player 1 win or player 2 win. Then that player need to set aside the winning card here. And how does the player set aside the winning card? Because player keep track of its winning pile. So this is a sequence of action. So when we play the CRC card, pretty much it's about you have an action to carry out. Then which objects are involved? Which object can do what? So for example, when you play card, player starts the action by play card, then hand remove the card, then game do the determination, then give the winning player the card, and the player will add that card to its winning pile. So this is a sequence of action carried out by a set of collaborating objects. Now let's take a look at the draw the replacement card. Draw the replacement card. So still start with the player. Player draws a card, and the deck should get involved because deck has to deal the card, and the hand need to add the card. So again, 3 objects collaboration. End the game. For this scenario, game knows about the deck, and so game know when it should be empty. So when deck is empty, game knows about the player, and it can compare the player's winning pile to determine who wins the game. So the involving objects here are the game, deck, and player. Thank you. In the next part of the video, we are going to focus on the implementation part. In this part of the video, we're going to look at the implementation part of the WOW project. Here are the UML class diagram. The UML class diagram has three parts. The first one, as you can see, that's the name of the class, then the property of the object. So for card, I also modeled suit here. Suit is useless for this application because we don't do much about suit at all. We only care about the ranking, but I put it in there just to show you. Then let's see, here are all the functions, the member functions. There are two constructors and two getter function. Let's take a look at the UML function. How do you define the method of function? That's a function name, and if it takes parameter, that will be the argument name, the parameter name, colon, then the type of the parameter. So suit is a data type here, and the ranks data type is an integer. So by looking at this UML class diagram, pretty much you can come up with a header file in C++, the prototype of this card class. Now let's take a look at the DAC. So DAC, to model DAC, I use a vector of card. And when I use a vector of card, I don't really do vector of card. It's a vector of pointers to card. You will see in this project, I use pointer to card everywhere. So you can imagine that's shadow copy. So when I move one card from the deck to the player give it to the hand, it's just a pointer. It's not heavy moving. It's a shadow copy, just a pointer moving. It's much more efficient that way. Now let's see the member function for DAC. Here's a constructor, and DAC need to know how to shuffle cards, and the constructor should create all the cards and how to shuffle cards, how to deal a card. Deal a card need to give back a card, so it's given back through the parameter. And the return type here is Boolean. So this is how do you say the return type of a function? It will be the function name followed by parameter list, then the colon. So the return type is a Boolean. Similar here is empty. Now let's take a look at the player class. Player class need to keep track of hand. So hand is just a hand object, and the winning pile. For this application, the winning pile is, we can just use the integer to keep track of how many cards this player won. Now the constructor, maybe you want to initialize the hand and initialize the winning pile, and how to draw a card. In order to draw a card, this player class need help from the deck object. The deck object has to deal a card, and to play a card, it has to give back a card, and set aside the card, it has to add the card to its winning pile, and get score to give back the number of cards on the winning pile there. Now let's take a look at the hand. A hand is just a vector of card. Again, it's a card pointer, just like the deck. And for hand, you only have two actions: add card, remove card. Now let's see the game controller object for game. Game knows about the players and the deck. And for this game class, there's a constructor and there's a run function. So all the game logic is in the run function. So this controller will determine who goes, who wins, when the game will end. So that's a UML class diagram for this application. Now let's take a look at the implementation. The implementation should be straightforward to you. The only thing I want to point out is about the usage of vector class. That's STL container. Now let's see. For card, it doesn't use a vector. The card just has a suit and has a rank, suit and rank here. And suit is an enumeration type. And so that's card. Card is very straightforward, like I said. So I'm going to show you about DAC. For DAC, we use a vector to keep track of the cards. And if you never used vector before, this is a good place to get started. The C++.com vector is in, so you can go to reference, then go to containers, and vector is one kind of container. So if you click on vector here, I like this website because it has an official document, and it also have very short sample code to show you how to use a specific function. That's very helpful. Let's take a look at the vector. So if I click on this vector class, it shows you what this class does and how it's implemented, and the efficiency. We learned in data structure about big O notation and what's behind the scene vectors, how vectors implemented, the efficiency concern here, and container property. So those are the official document for vector class. And what I want to show you is about individual member function. For example, when you use vector, you need to know how to create a vector. So you need to know about the constructors. So if you click on constructor here, it shows you vector has quite a few constructor and what they do, each individual constructor. And you see this sample code, it's always less than 20 lines of code and show you exactly what you need. So it shows you how to create vector using different constructors. It's very helpful. Now here, in order to model DAG, I have a vector of pointers to card. I'm going to show you the detailed implementation about using vector. Let's see, in the DAG.cpp class. So for the constructor, I need to create a deck of cards, and this cards is a vector, so I just use the pushback function to add the card. And as you can see, when I add to the cards to this vector, I didn't add the real card, I add the pointer to the card. And remember, new card give you back the pointer to the card. Now let's see the destructor. The destructor, I use this iterator. So the iterator data type, iterator is a very powerful idea. Iterator allow you to iterate through a container using very similar way. It doesn't matter if it's a vector, if it's a list, if it's a DAG, if it's something else. It's a very unified interface here. Iterator, so you see this one, the inside the vector, there's an iterator type. And you can do it this way. Say, I'll start, begin, give you back the starting point of the container. So you can imagine iterator as a pointer to the container. And this one give you the pointer to the beginning of the container. This one give you the pointer to the end of the container. To iterate through it, we do a dereference this iterator that give you to the individual element inside this vector. For us, that's a pointer to card. For the destructor, we need to delete the card. So that's where the syntax comes from. And about the shuffle cards, here, when you do the shuffling, you need to use the seed. And this is how you get the time-based seed. And how do you do shuffle? Shuffle is a function in algorithm. So in the STL library, we have a bunch of containers and we have algorithm. Algorithm contains some sorting, searching algorithm, and frequently used actions. You can take a look at the algorithm header file to see what kind of service algorithm provide. And this shuffle is one function in that algorithm algorithm library. Let's see, for the deal card, you first do the checking to see if you can deal, and then you get back and do the pop back. Those are all vector member functions, and it's empty, it's straightforward. And for the print function, you see here, I use a new feature of C++ 11. this iterator data type is pretty complicated. You see this iterator data type, I gave you an example here. It's inside the vector, there's an iterator class, and the new feature, new C++11 feature allow you to use auto. Auto is just leave the compiler to figure it out. So you get the beginning. You see here I use C begin and C end. That's for the constant. That means you're not going to modify this card. Because for print function, this print function I declared as a constant member function. That means it's not going to modify any data members. And when you use the iterator, you have to use the C begin to say, I use this iterator while I'm iterating, I'm not going to modify it. So that's the C begin and the C end. So that's about the implementation of DAC. And for game is pretty simple. Let's just keep track of the player and the DAC. And for the run function, let's see, the run function is where your game logic, you see, you first shuffle the DAC, then deal the initial card, then start playing, and determine who wins, and when will the game end. So that's a game class. And for hand is just a simple class to model a collection of hand. Again, we use vector to do that. And for player keep track of two things, the hand and the winning pile. Let's see, player can draw a card. In order to draw a card, it needs DAC's help. And it can play a card, it can set aside a card, it can get score. So that's about the player class. For all the classes here, the relationship among those classes, pretty much in this application we only see two of them. One has a relationship. For example, player has a hand. So player and hand class, that has a relationship. And also as DAC has a bunch of cards that has a relationship or contains something. And another relationship we see is in the player class. You see the deal card, the player class, let's see. The player class, when player try to draw a card, it needs DAC's object's help, this DAC object's help. So that's a use a relationship. Has a relationship meaning I have something like player has a hand and the player knows about this hand all the time. The relationship is permanent. This use a relationship, usually it's just for one function, for one member function or for one method, I need to use this object. You see, player and the DAC, that's not a has a relationship, that's a use a relationship. It only use DAC for this specific function. So that's a true relationship. In the future of this term, we are going to see more relationship, namely is a relationship. Thank you. That ends the discussion of this WAL project.